So I suppose during the period when I went back to Kosterlitz as a postdoctoral fellow, so this was 74, 75, then sure, I was trying to work out what morphine and opiates did to single nerve cells. So that was a little bit parallel to the main activity of his lab. The main activity of his lab had for many years been studying morphine and similar drugs of abuse on isolated tissue preparations. And he'd been doing this from the late 60s. He'd found a way of predicting opiate-like activity by looking at their actions on various tissues removed from the animal and kept in vitro. So one of these was a piece of the intestine from a guinea pig. Another one was the vas deferens from a mouse, for example. And there were several pieces of tissue like this. It could be maintained alive for several hours in vitro. What Kosterlitz had found was that if you take several opiate drugs like morphine, heroin, codeine, pethidine, then their ability to act on these isolated tissues very closely tracked their effects in man to relieve pain. So he had become accepted as the real guru of predicting the activity of opiate-like drugs. So it was natural to think that if the receptors were so clearly definable on the basis of the actions of a series of drugs on them, then why wouldn't there be a natural ligand for the opiate receptor? When he started to look for that, so he recruited John Hughes to Aberdeen in about 1970 or 71, and that's when the first ideas were beginning to be discussed about an endogenous ligand. The obvious thing was to simply take the brain, mash up the brain, extract the material from it, and see if it had an effect on these isolated preparations that was similar to that of morphine. And the key test depended on the antagonist for all the morphine actions, which is naloxone. It's a morphine analog widely used clinically to treat people with heroin overdose because it's a pure antagonist at the opiate receptors. The key test became if there was any activity in an extract from the brain which looked on the isolated tissues to be like morphine, then it must be reversed by naloxone. And they had not worked very long before they found material in the extract which inhibited the contraction of the mouse vas deferens, and that was reversed by naloxone. So those findings were made in about 1973. I think they were published in a brain research paper in 1974. There was no identity of the material, but it was quite clear that there was a material. And I think this is a material with opiate-like properties. I think this is what really got Sol Snyder excited and Lars Terenius. This is really when Eric Simon, this is what really drove them into a frenzy. The fact that there was someone in Aberdeen, they'd already got the activity, biological activity. The group in Aberdeen had one unique advantage. They did their assays for this material on a living piece of tissue. The other people were doing their assays for the material by looking at its ability to displace radioactive morphine or a similar molecule. So it was possible for them to find an artifact. It would be something that would displace the radioactive morphine, but it might not have the biological activity. The nice thing about the Aberdeen approach was that it was based on what's called bioassay. That is, they were testing the unknown by seeing its biological effect. And because of Kosterlitz's huge background experience on opiates, he knew that this biological effect resulted from occupation of the opiate receptor. I think the period through 1974 and into 75 was really quite frenetic. I moved to the United States in 75, and in May of that year, just after I'd arrived in the States, I attended the meeting of the International Narcotics Research Conference at Ailey House in Virginia. There was clearly a great undercurrent, and nobody was talking very much about how far they were down the road. Lars Terenius, we all thought he was extremely close. Eric Simon, we all thought he was close. But see, all these people were looking at the displacement of radioactive compounds. And I think that must have been a very slow way to go. In fact, the Aberdeen group did not know the identity of it at that time. It was only after that they took it to the mass, they realized it was a peptide, and they took it to the mass spectrometry, and they discovered, in fact, it was a mixture of two peptides. And then the paper appeared in the 18th of December 1975, the Nature paper. This enkephalin was the beginning of the real era of peptides, which took off in the late 70s and ran for about 10 years.